Welcome back to Unit 3 of Advanced Higher Chemistry. This is going to be a short video on the technique of colorimetry. So what is colorimetry? Well, colorimetry is used to measure the concentration of coloured chemicals. We spell colorimetry the American way. You will not get marked down if you do put a U in the word colorimetry, okay? So don't worry about that. The equipment we use is called a colorimeter, or sometimes it's known as a spectrophotometer. Both mean the same thing and they work in the same way. Now what happens is that coloured light will be passed through your sample and you will measure how much light is absorbed. By comparing the absorbance value against a calibration curve you have created from some standard solutions, the concentration of a sample can be determined. So obviously we need a calibration graph, sometimes called a calibration curve, and we need to know how to do that. So there are a few steps. So the first one is make sure you prepare a series of standard solutions. Now you need to make sure that your anticipated concentration of your sample falls within the range of the standard solutions you're measuring, because you're going to be using the graph that you generate to measure the concentration. So you need to make sure that your concentration falls somewhere within your series of standard solutions. You then need to choose an appropriate wavelength or filter for the colorimeter that is complementary to your sample. So we'll talk a bit more detail about how to do that and what is meant by a filter, but you need to choose the right filter. Then you need to do something called a blank. Now a blank basically measures the absorbance of that particular coloured light in whatever solvent you're using. For the majority of the experiments that you would do, your solvent is going to be something like water. So a blank sample is like a control, and it's just using water, and it's measuring what water is, and that sets a reference point. Now most colorimeters and spectrophotometers will save the blank on it, and then all measurements it will take will be in reference to the blank. So it's not like you need to do anything with the blank other than make sure that you have measured it. And the fourth thing you need to do is that once you've sampled the blank, you sample the absorbance of each of your standard solutions. So you sample them, measure the absorbance, and then plot a graph of concentration against absorbance. Concentration on the x-axis, absorbance on the y-axis. And that is your calibration curve. It's called a curve, but most of the time you are expecting and wanting a straight line. Now, how does a filter work? Well, the light source for most spectrophotometers and colorimeters is white light. White light is made up of every single colour. Now, when you've got a coloured compound, it's usually coloured because it's absorbing a specific wavelength. What a filter does is it only allows a particular wavelength through. So for example, the filter that's been represented by a triangle here is only letting blue light through. It's that blue light that's passed through your sample, and you're measuring how well your sample absorbs blue light. You want to choose the colour filter that your sample is going to have the highest absorbance for, because that will give you your most reliable information. So how do we know how to choose a filter? Well, remember from transition metal complexes, the colour that a chemical appears is complementary, which means opposite, to the colour it absorbs. So if whatever colour a sample is, you look on the opposite side of the colour wheel, and that will tell you what filter to use. So for example, if you have a purple or violet compound, what you would choose is a green or a yellow-green filter. Filters can be labelled based on colours, but quite frequently they'll also be labelled based on wavelength. So those are the nanometers written around it. So whatever colour your sample absorbs, which is the opposite to the colour that it is the colour or wavelength of your filter. And finally, just to finish this off, is how to use your calibration graph. So once you have prepared your sample, and you prepare your sample in a similar way, using the same solvent as you would your standard solutions, you can then measure its absorbance. Now you take the absorbance value you've measured and you go to that part on your calibration graph, read across to your line of best fit and read down to your concentration. Now obviously what you need to do is to take several measurements to make sure that your results are reliable and then take an average of the concentrations. Ideally, you would end up with exactly the same absorbance and therefore the exact same concentration each time. So this is only used for coloured compounds. So common experiments would be measuring the concentration of transition metal complexes or transition metals that you make a complex to measure the concentration of that transition metal. It can also be used to measure the concentration of naturally coloured compounds, such as things like potassium permanganate, which is bright pink, or dichromate, which is orange, or even things like hemoglobin or chlorophyll, which have natural colours to them. So that's been a quick video on how to set up and do a colorimetry experiment and how to choose and understand why you need filters for that.